Hello and welcome to the session. In this video, we discussed two important concepts which are very important for a data scientist or it's very important in machine learning: covariance and correlation. Let's try to understand what it is and what's the difference between covariance and correlation. Now, as a machine learning engineer, or if you are learning data science, it's very important that you understand these two terms and also understand the difference between these two terms, correlation and covariance. So before learning the difference between correlation and covariance, you need to learn what is variance. Okay, so variance basically measures the spread between all the data points in a data set. So it actually shows how far is each data point from the mean value. So the formula for calculating the variance is you are measuring the difference of each data point with the mean value. So therefore it's a difference between x minus x bar. X bar is the mean. So you're finding the difference between each data point with its mean value. So x minus x bar, the whole square, and you take the summation. So for every data point you take the difference with the mean value, square it and then sum it up, and totally divided by n minus 1. So this is a formula for calculating the variance. So basically this s square v is used, this is actually s square is used to represent the variance, and this is a summation. X is the value of data point, x square is a mean of all the data points, and n is the total number of observations. So variance is represented by s square. So coming to covariance, now covariance finds the direction of relationship between the two data points. So covariance is all about direction. So it finds whether the two data points are directly proportional or inversely proportional. So you're finding the relationship between two data points, particularly the direction. So the formula for calculating the covariance is, since now we are talking about finding relationship between two data points, let's say the two data points are xi and yi. So each one we have to subtract with its mean. So xi minus x bar into yi minus y bar. You take for each data point xi and yi, subtract it with its respective mean, each data point, and then sum them all together, and then finally divide by n minus 1. So that will give you the covariance. So covariance is represented as COV x comma y. So this is a common notation of covariance. So basically it represents covariance between x and y, and n is the total number of values. The third term, that is correlation. Now this is also used to find the relationship between data points. Now that's the thing, right? Both covariance and correlation are used to find the relationship between data points, but covariance finds the direction of relationship, whereas what happens in correlation, it finds a direction of relationship along with the degree of relationship. So that's the difference. Okay, relation finds the direction of relationship along with the degree of relationship. So covariance we just saw in the previous slide only measures whether the two data points are inversely or directly related to each other. But correlation measures the strength of the relationship between the two data points. So that's the main difference. Covariance will measure the direction, right, directly or inversely proportional, but correlation will measure the strength of the relationship between the two data points. So that's why I said it not only finds the direction but also measures the degree of relationship. How what's the degree of the relationship, or what is the strength of the relationship between the two data points, and hence the formula for correlation will involve finding the covariance before that. So you need to find covariance before this. The covariance formula we just saw in the previous slide, this one, right? First find the covariance and then you find the correlation. So covariance will be the numerator. So covariance of x comma y you need to find, put that in a numerator, divided by the standard deviation of x minus the standard deviation of y. So that would give you the correlation. So I hope the main difference is clear. Covariance Both covariance and correlation are used to find the relationship between two data points, but covariance will only find the relationship whether it's directly or inversely proportional, but correlation, it will not only find the direction, it will also find the degree or the strength of the relationship. So that is why in the formula of correlation we need to use covariance should be first calculated and then you find the correlation. So basically, as I said, now we have just seen three terms now. Variance we learned first. Basically, it measures the spread between all the data points in a data set. Then you have covariance, where you find whether the two data points are directly or inversely proportional. Then you have correlation, where you find the direction of relationship along with the degree of relationship. So these are the three differences. Now, the question is, when do you use covariance in your algorithms? When do you use correlation in your algorithms? See, I can use covariance if I want to see if the two things will change together or not. Okay, so I will use covariance if I have to compare two data points, whether they are changing together or not. But correlation I will use when I want to see how strongly the two variables are related to each other. So then I will use correlation. So the application, some of the applications you can see is I can make a correlation matrix for three reasons. Right, correlation matrix means basically I'm finding the strength of the relationship. So I can use it when I'm dealing with large amounts of data where I want to find the patterns. So I will form a correlation matrix. The correlation matrix which I form will help to find the pattern in the data and determine whether the variables are highly correlated or not. So basically I will be forming the correlation matrix to find whether the variables are highly correlated or not. That means find the strength of the relationship between the variables, whether they are highly correlated or not. So that's the main purpose. And also I can use correlation concept when, or I can use correlation when I'm excluding missing values pairwise. Right, I'll be having a lot of mixing values, so when I exclude that pairwise, correlation matrices are commonly used, and basically they are the very good inputs for exploratory data analysis. It's very good when I am working on structural equation models. Correlation I can use when I'm working on linear regression. So these are some of the cases where I use correlation, and I also use correlation as a diagnostic purpose. I not only use it for checking the relationship, I use it as a diagnostic purpose. For example, when I'm working on linear regression, there'll be a large number of correlations existing, which indicates that the linear regression estimates will be unreliable or not. So when I'm working on linear regression, I can use correlation as a diagnostic to find out whether the estimates are good or not. Is it reliable or not? When I'm working on linear regression, I can use correlation. So next few sessions when I'll be talking about linear regression, we'll see this. So applications of covariance, we will be using covariance especially when we'll be working about different kinds of decomposition, SVD decomposition, linear LU decomposition in the next few sessions. Similarly, you have one more decomposition called as Koleski decomposition. So basically, where I'll be using multiple correlated variables, right? I'll be decomposing the matrix using Koleski decomposition. So covariance is very useful here, which will help me to determine the Koleski decomposition, because it's where I'm going to find out whether it is a positive semi-definite or not. So basically when I'm working on Koleski decomposition, I will be finding out the covariance, where the matrix is actually decomposed into product of lower matrix and its transpose. I will also be using covariance when I'm working on PCA. PCA, very important concept called as principal component analysis, where main purpose of PCA is to reduce the dimensions of the large data sets. So when I am doing principal component analysis, I'll be using eigen decomposition, where I will be using covariance matrix. So in the next few sessions, we will be seeing PCA, where we will see how we can do eigen decomposition using the covariance matrix. So this is the applications of covariance. So basically, to just summarize the difference between covariance and correlation, covariance measures how two variables change together, but correlation will tell how strongly they are related to each other. So basically the values, when you're finding covariance, the values will range from negative infinity to positive infinity, but correlation values will range from -1 to 1. So is there is a standardized way of doing it? No, but correlation, yes, there's a standardized way of doing it. We will be seeing in the next decomposition methods how we can do all this. So basically covariance will show the direction of the relationship. Correlation will show the direction and strength of the relationship. So that's it for today's session. Today's session was just a quick uh, discussion on the variance, covariance and correlation, basically focusing on the difference between covariance and correlation. I hope it was clear. In the next few sessions we will see a lot of these examples like LO decomposition, SVD decomposition, principal component analysis, where we will be coming across these terms. So thank you so much, and please subscribe to the channel. Thank you.